Hi gang, let's just fiddle around with this a little bit more. I'm just trying to do problems that are similar to your homework. So, all right, let's just talk a moment about another pre-calc concept, which are your logarithms. So let's talk about your log properties. So let's see if you remember this. Log of u times v. Do you remember how to break that? Good, that would be log of u plus log v. How about this one? Log of u over v. You would break that into log u minus log v. Good. And then this guy, log u to the r. Remember that one? That would be r log u. Okay. These are going to pop up every now and then, and you're going to need to be able to use them. I'm just looking at these problems over here. Now, in terms of evaluating, you should know off the top of your head the log of 1, right? You remember what that equals? That equals to 0. You guys remember what the log of e equals to? That equals to 1. You might want to just go over a little bit of your logarithms from pre-calc, just depending on how you feel about them. Now, let's see here. Let's try this one over here. Let me get the light a little better. All right, the limit as x goes to 0 of e to the negative x sine pi x. So remember, you want to plug in. So this is e to the 0 times sine. Now pi times 0 is 0. So now you've noticed I've lost the limit because I plugged in. Now e to the 0, anything to the 0, you remember what that is? That's a 1. Sine to the 0, that's quadrantal. You should be using your unit circle for that. So sine of 0 is 0. That's unit circle. So you got 1 times 0 is 0. So the final answer to this is 0. Because 1 times 0 is 0. So you may just want to go over some of these rules. Let me see what this guy looks like. Number 36. Limit. Oops, sorry. That is some kind of fire alarm going off. Like we don't have enough other issues happening. Always more excitement. I think we just have to laugh at it at this point. All right, I'm going to plug in a 1, so limit of 1 over e. You could write e to the 1 if you want, but e is fine. Now, it just depends how you want to do this. Just so we can practice, let's use this rule, okay? This breaks to this, so let's go ahead and use that rule. And again, stop the video anywhere just so you can practice a concept and then check with me. So I use that rule. The limit of the division is the limit of the top, sorry. My brain needs to say logarithm. So the logarithm of this is the logarithm of 1 minus the logarithm of e, right? You're doing the second rule here. All right, now I just went over this. Do you remember what I said? The logarithm of 1, that equals to 0. The logarithm of e equals to 1. So 0 minus 1 or minus 1. Right, I was just talking about that. Those two will pop up, and there you go, they did. Okay, let me just eyeball real quick. This is towards the end now of what I want. What's really, not only is calculus like a super interesting topic, you're going to find it's also less stressful than pre-calc, just on the basic fact that whether you think the content is more difficult or not is not, I don't think you're going to find that a problem, because I think it's way less content than pre-calc, so you'll have a lot more time to focus on learning versus like, I won't be cramming a ton of stuff down your throat. There's less content here than there is in pre-calc, which is nice. This will be more comfortable. Now these look more sophisticated than they are. So like for instance, number 38 here, it says 4 times the limit of 4 times f. So you would take 4, multiply it by the limit of f, which is 2. So the answer to this is 8. So this looks harder than it is. Limit of f plus g means that you're adding the limits together. So you're doing 2 plus 3/4, then you want to get an LCD. So what are you going to get here? 8/4 plus 3/4 is 11/4, right? Here you're going to do the limit of their product. So you would just multiply this, 2 times this, that would end up being 6/4, which would reduce to 3/2. And here you would take their quotient. So f divided by g, so 2 divided by that, but you'd have to flip it and make it 8/6. Okay, so these look complicated, but it's literally you're just plugging in the values for the limit into whatever operation they're telling you to do. Okay, so don't let this knock you off. And that's where I ended it, because after that we sort of get into some technique. So mostly everything I've given you up to here is pretty much like pre-calc or just a straight plug-in. There isn't any like extra steps or tricks or anything like that. All right, I just want to make sure in terms of notes that I've just sort of said my spiel, and you can, you can review this video and go back over it. All right, so I usually hand out these packets. I love these packets because there's just like a lot of little rules you got to watch out for, and calculus is also very visual. So this page here, the packet, is just asking you to be mindful of the domain of a function. And it's basically saying you can, you can plug and chug as long as you're not on a domain restriction. We went over this sort of, I didn't say it as explicitly as I was saying in your notes, but it's basically saying as long as it's not a domain restriction, you can just plug in. This is just saying you can plug in. So the sine and the cosine, if you recall, the domain is all real numbers for these. It's these other 4 at the bottom that all have vertical asymptotes. So these 4 on the bottom can get tricky, and we didn't really, I don't think, got into them too much. In terms of the vertical asymptotes, but we will be visiting these in terms of their vertical asymptotes. But I think mostly everything we've done has been just has had an answer. Okay, and I'm not going to start this yet. We're going to start that next week. Okay, gang, so again, for this section here, this 2.3, I just gave you some basic, just plug and chug type of problems, and so we can just sort of warm up and get back into the action here. Welcome back. I'm looking forward to having a really nice semester with you guys, and I will catch you. I'll catch you next week. Okay, bye-bye.